Hello everyone. So kule video sizobheka ama-corrections we-exercise ye-analytical geometry. Right, so in the diagram below, PQRS is a rectangle with vertices P, Q, R and S. Q lies in the first quadrant, right? And then first question, they say show that the value of A is equals to 4, right? So masibheka u-A ulapha kuma-coordinates ka-Q, right? So in order for us to show the value of A is 4, we need to apply some concepts for analytical geometry, right? So we can also see from the sketch that angle at Q is 90 degrees, right? Siyazi all the angles in a rectangle are 90 degrees. Therefore, the gradient of PQ multiplied by the gradient of QR will be equals to -1 because these two lines are perpendicular, right? So lapho 5.1 masithi the gradient of PQ multiplied by the gradient of QR should give us -1 because PQ is perpendicular to QR, right? So the gradient of PQ, we're gonna take y at P minus y at Q divided by x at P minus x at Q minus x at Q, right, multiplied by the gradient of QR. We're going to take y at Q minus y at R divided by x at Q minus x at R, right? And we want to, this should be equals to -1 because the two lines are perpendicular, right? So now we just substitute the coordinates into our equation of the gradient, or into our formula of the gradient, right? So y at P, we see at P y is 0, so there we're just gonna put 0, and at Q we see y is A, so there we're gonna put A. X at P is -4, so here I'll have -4. X at Q is 4, so I'll -4, right? Multiplied by y at Q is A, so here I'll have A. Y at R is 0, so there I'll have 0. X at Q is 4, x at R is 6. This should be equals to -1, right? And then now multiplying the numerator, we see lapho we're gonna have 0 minus A, which is gonna be -A, and then here we have A minus 0, which is gonna be A. So go numerator, we have -A times A, which is gonna be -A squared, right? And then denominator, we see we're gonna have -8 times -2. This is gonna be -16, right? Sorry, it's gonna be 16 because we're saying -8 times -2, it's gonna be 16, right? And then now we can solve for A. We're gonna have A squared is equals to -16, right? A squared is equals to 16, and then A is equals to plus of minus the square root of 16, which is 4. A is equals to plus of -4. But then we see on this quadrant the value of y is positive, therefore A has to be greater than 0, which means that A is equals to 4. We're just gonna take the positive square root of 16, which is 4, right? So there we have shown A is 4, right? And then we move on to question 5.2. So question 5.2 bathi determine the equation of the straight line passing through the points S and R in the form of y equals to mx plus c, right? The equation of the line passing through the points S, this is the point S and R. Okay, so they want us to determine the equation of this line, right? So in order to determine the equation of the straight line, we will need to calculate the gradient and calculate the y-intercept, because our equation is in the form of y equals to mx plus c. So we need to calculate the gradient and then we need to calculate the y-intercept, right? But then we don't know the coordinates of s, sorry. So which means that we can't calculate the gradient of the line SR directly, but then we see with the line SR is parallel to the line PQ. Therefore, the gradient of PQ will be the same as the gradient of SR, right? So if we can calculate the gradient of PQ, that gradient will also be the gradient of SR because these two lines are parallel, right? So MPQ will be equals to MSR, right? Will be equals to MSR because PQ and SR are parallel, right? So I'm gonna go ahead and calculate the gradient of PQ, right? That will be y at P, which is 0, minus y at Q, which is A, which we showed which is 4, and then x at P is minus 4, x at Q is 4, gonna subtract 4, right? This will be the same as the gradient of SR. So here I'll have minus 4 divided by minus 8, it's gonna be 1 over 2, right? So the gradient of SR is 1 over 2. So now my equation of the straight line will be 1 over 2x plus c. Right, now I need to calculate the value of c. In order to calculate the value of c, I will use the point r and substitute into my equation. Right, I see that at r y is 0 and then x is 6. So here I'll have 1 over 2 times 6 plus c. So I'll have 6 over 2, it's gonna be 3, and then take 3 to the other side. I'll have c to be equals to minus 3. Therefore my equation will be 1 over 2x minus 3, right? So y will be equals to 1 over 2x minus 3. That will be my equation. Okay, and then now we go on to 5.3. 5.3, they want us to calculate the coordinates of S, right? So in order to calculate the coordinates of S, we'll use the fact that PS is perpendicular to SR, and also use the fact that the gradient of PS is the same as the gradient of QR, right? Okay, so to calculate the coordinates of S, I'll say, okay, S, the gradient of PS times the gradient of SR. PS is this line, SR is that line. So the gradient of PS times the gradient of SR will be minus 1 because these two lines are perpendicular, right? So let us calculate the gradient of PS. So the gradient of PS will be y at P, which is 0, minus y at S, which we don't know. So this is what we want to calculate, y at S, right? Divided by x at P is minus 4, x at S we don't know, right? Times the gradient of SR, right? So to calculate the gradient of SR, I will say y at S I don't know, and then y at R is 0. X at S I don't know, x at R is 6. This should be minus 1. Okay, so here I'll have minus y squared divided by minus 4, minus, okay, notice what I can rewrite minus 4 minus x as minus x times, as minus times the brackets of x minus x plus 4, I can rewrite this as the negative 1 times x plus 4. Okay, so there I'll have xs plus 4 times xs minus 6 equals to minus 1. Okay, and then after we see that negative and that negative will cancel, so here we'll have, so there we'll have y squared divided by x plus 4 times x minus 6. Okay, x plus 4 times x minus 6. Right, so y squared will be equals to minus xs plus 4 times x minus 6. Right, and then now I'll call this equation 1, and then I'll go on and use the fact that the gradient of PS and the gradient of QR should be equal to each other because the two lines are parallel. Right, so I'll say MPS should be equals to MQR because PS and QR are parallel. Right, so yeah, the gradient of PS will be equals to y at P, which is 0 minus y at S, which we don't know, divided by x at P, which is minus 4, and then minus x at S, which we don't know, multiplied by this will be equals to the gradient of QR. The gradient of QR will be calculated as y at Q, which is gonna be 4, minus y at R is gonna be 0, divided by x at Q is 4, minus x at R is 6. Right, so here we'll have 4 over minus, so here we'll have 4 minus 0 is 4, 4 minus 6 is minus 2. Right, so we're gonna have 4 divided by minus 2, which is just minus 2. Okay, so we're gonna have 4 divided by minus 2, which will give us minus 2. So this will be equals to minus 2. Right, and then now we can say, okay, we can say from this y at S will be equals to minus 2. Okay, let me go back a bit. Again, we can rewrite minus 4 minus x as minus x plus 4. Right, okay, so there I'll have, instead of minus 4 minus x, I'll have minus 1 times x plus 4. Okay, I'll have minus 1 times x plus 4. Right, so I'll have minus, and then that minus and that minus will cancel. Right, so I'll have minus 1 times x s plus 4. Okay, and then now I can solve for ys. Ys is equals to minus 2 times xs plus 4. That will be my equation 2. This will be my equation 2. Okay, that will be my equation 2. And then now I can substitute wherever I see y squared in equation 1, I'll substitute with minus 2 times x plus 4, right? So substituting this into equation 1, I'll get minus 2xs plus 4 squared all squared, right? So it will be minus 2 times xs plus 4 all squared is equals to minus xs plus 4 xs minus 6, right? And then minus 2 squared will be 4, and then xs plus 4 squared is equals to minus xs plus 4 xs minus 6, right? So here I'll have, if I divide by xs plus 4, I'll have, okay, I'll just continue this side because of space. I'll have, if I divide by xs plus 4, on the left hand side I'll have 4 times xs plus 4, and then on the right hand side I'll have minus xs minus 6, right? And then here I'll have 4x plus 16 is equals to minus x plus 6, right? And then I'll have 5x is equals to 6 minus 16, sorry, 6 minus 16 will be minus 10, right? Therefore xs is equals to minus 10 divided by 5 is equals to 2, minus 2, right? And then taking this answer of minus 2 back into my equation 2, I can calculate the value of ys. So ys will be equals to minus 2 times minus 2 plus 4. This will be minus 2 times 2, it's gonna be minus 4, right? So the coordinates of s will be minus 2 minus 4. Okay, so I think I sort of like took a longer approach. If you did it some other way, it's fine. I feel like eminently limited, it's quite a long approach. Yeah? Maybe there's an easier way of doing it. Okay, and then now we'll go on to 5.4. So 5.4, but to calculate the length of PR, right? So we see with the PR is just this horizontal line from here to there. They want us to calculate the length of this line, right? PR. So PR will be equals to 6 minus 4 will be 10 units. Notice the answer was so quick, and then with Lana we only getting 2 marks for our answer. Okay, so that was 5.4. PR is equals to 10 units. And then we go on to 5.5. 5.5, but determine the equation of the circle that has diameter PR. Given give the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared, right? So now the diameter of that circle will be PR. We just calculated what the PR is 10 units. So if the diameter is 10 units, it means the radius is 5 units. So lapha ku 5.5 the value of r will be 5, right, because it's the radius. Right, so now we have the value of r. We need to calculate the value of a and the value of b. Notice with those values will sort of determine the center of the circle, right? So the circle will be centered at x equals to a and y equals to b, right? So now to calculate the center of the circle, I'll calculate the midpoint of the line PR. So the midpoint, so if we sort of like imagine our circle, it will sort of look like this, right? Imagine this is a circle. I know it's not a circle, but imagine it's the circle, right? So we need to calculate the coordinates of the center of that circle, right? So in order to do so, notice if the diameter is PR, the diameter will pass through the center of the circle, right? Now if I know the length of the diameter is 10 units, then my radius will be 5 units, meaning the center of the circle will be the midpoint between P and Q. The midpoint of PR will be the center of the circle. Yeah? So if we calculate the midpoint of PR, we will know the center of the circle. Right, so I'll say let M be the midpoint of PR, right? Therefore M will be x at P will be equals to x at P plus x at R divided by 2. X at P is minus 4, x at R is 6 divided by 2. And then the y coordinate of the midpoint will be y at P is 0 plus y at R is 0 divided by 2. So the midpoint will have minus 4 plus 6 is 2 divided by 2 is 1, and then 0 plus 0 is 0 divided by 2 is 0, right? So the circle is centered at the point 1 0, right? So from this I can see my A should be 1 and my B should be 0, right? So now to calculate the equation of the circle will be equals to x minus a is 1, so it's x minus 1 squared, plus y minus b is 0, so we'll have y minus 0, which is just y, all squared will have y squared, equals to the value of r squared. We said r is the radius and we calculated that to be 5. So 5 squared is equals to 25. And there we have our equation of the circle. Right, and then 5.6, but to show that Q is a point on the circle. To show that Q is the point on the circle, if we substitute the coordinates of Q into this equation, into the left hand side of this equation, we should get 25, right? So if I say 4, x at Q is 4 minus 1 squared plus y at Q is 4 also. So calculating this, 4 minus 1 is 3 squared. So if I just punch this in my calculator straight away, I'll have 4 minus 1 squared plus 4 squared. I get 25. This is equals to 25. Therefore the left hand side is equals to the right hand side, right? So we can conclude that Q is in the circle, is on the circle, right? And then we go on to 5.7. So 5.7, but the rectangle PQRS undergoes the transformation from x to x plus k and from y to y plus l, where k and l are numbers what is the minimum value of K plus L so that the image of PQRS lies in the first quadrant, right? So how should we transform this rectangle so that it lies in the first quadrant, right? So if I shift this point P 4 units to the right, it will come here, right? And then if I shift this point Q 4 units up, it will come there, right? So after shifting P 4 units to the right, I'll sort of have my rectangle to look like this, right? It will sort of look like this, right? And then I want it to lie completely in the first quadrant, which means I need to shift this point up, right? By how many units? Now this point will be S. S will go from there to there. Now I need to shift it up by 4 units, right? So I'll shift. So in order for this rectangle to lie in the first quadrant, I'll shift it 4 units to the right and 4 units up, right? So it means if I say K is equals to 4 and L is equals to 4, I'll have this rectangle to be completely in the first quadrant. So now the minimum value of K plus L will be 8, right? So K plus L will be equals to 4 plus 4, which is 8. So the minimum value is 8, right? The minimum value is 8. The minimum value is 8. Okay, so yeah, that concludes the corrections for this question. I hope everything makes sense. If it doesn't, you know what to do. Feel free to ask me there on WhatsApp.